When we want to graph a piecewise function, what we want to do is we want to come in and we want to create a t-chart for each of the pieces. For our first piece, we have x less than or equal to -3. Since we have an equal sign here, that equal sign is going to tell us that we fill in the circle, or that is, we have a closed circle at x equals 3, -3. So we're going to come in, create a t-chart where we have our x values, and then we have our y values, where y is x plus 2, because that's the function part that corresponds with x less than or equal to -3. We want to use that endpoint of -3, and then we want to choose one more value. So let's perhaps try a -4. When x is -3, -3 plus 2 is going to be -1. For x equals -4, we get -4 plus 2 is -2. So we need a circle at the point -3, -1, and this one will be closed. And we need another circle at -4, -2. We're not really worried about making that closed because it's going to be an interior point. It will necessarily be included. Next, what we want to do is we want to make a t-chart for the values between x equals, when x is between -3 and -4. So -3 is less than x is less than 4. Since we don't have an equal sign on either of these, we will have open or empty circles. For those x values. And on our t-chart, since we have two endpoints, we're going to use those endpoints, -3 and 4. And we have our x column and y equals 0 for this section of our graph. So when x is -3, we get y is 0. When x is 4, we get y is 0. So we have open circles at -3, 0, and 4, 0. Last, I want to look at the last piece of our graph, and that is when x is greater than or equal to 4. For x greater than or equal to 4, notice we have an equal sign here, so we're going to have a closed circle. And our function takes on the value 1/2 x. So we have x and y equals 1/2 x. We know we want to use the endpoint of 4, and now we need another value that is greater than or equal to 4. I would choose an even number because I know I'm going to multiply it by 1/2. So let's take perhaps an 8. So when x is 4, y equals 1/2 times 4 is 2. When x is 8, we get 1/2 times 8, which is 4. So we have closed circles at the points 4, 2, and 8, 4. So let's go and look at our graph and see which of these follow those conditions. Okay, so for each of these graphs, notice our scale goes to 20 and we have 1, 2, 3, 4, 5 tick marks. So what that means is each of those tick marks is worth 20 divided by 5 is 4. So this will be a 4 on our x value. Our y value goes to 8, and we have 1, 2, 3, 4 tick marks. So each of the tick marks on our y-axis will be worth 2. So we wanted a closed filled-in circle at -3, -1. And it looks like we have that probably right here. We also want a closed circle or a point at -4, -2. And we do have that point here. Let's check our next graph for these two values. We have a point at -3, -1, but notice it's an empty open circle in this picture. So we're going to exclude B. For C, remember our point is -3, -1. So that was right here. We don't have a point at all on the graph. So we're going to exclude C as a possibility. And when we go to D, again, we don't have a point at all at -3, -1. So that is not a valid solution. Now I want you to notice at -3, 0, A does indeed have an open empty circle. And likewise, at our other point, 4, 0, this choice also has an open or empty circle. If we check on the last values we had point plotted, we wanted closed points at 4, 2 and 8, 4. And again, we have a closed point here at 4, 2, and at 8, 4, we have a point. So we can verify that A is indeed the valid solution we want.